All right, hello once again, Jeff Scott of Rankin Technical College, and I've been going over bits and pieces of the book Murach's Android Programming, second edition by Joel Murach. I've spent most of the last several lectures going over what is in chapters 1 through 4 of the book, that is the tip calculator program. Then we went over chapter 5, and I built a bunch of controls on just a simple program. In chapter 6, they talk about handling events, and they distinguish between low-level events and high-level events. Now remember that when you've got an event listener, that's something that you add to the program, that you can kind of look at it in a way that your program is sitting there listening, waiting for something to happen. And when something does happen, the program will respond to the event, but the program will only respond to the event if you will put some code in there to make it respond. So when the event occurs on I don't know, like a button, for example, the associated on-click listener will be executed, and any code you put in there will run. So you've got high-level events that occur on a specific type of widget. All right, and here's examples of high-level events right here. I'm not going to run through any of them, but you see them. Then you've got low-level events that basically occur on any type of widget. So, for example, the edit text will have an on-edit action listener, etc. The seek bar will have, and you've seen some of these. Whereas anything that's under the view, so this will fire if you click on a button, or if you click on a text view, or if you click on an edit text, etc. So they go through here 4 different techniques for handling events. And the first technique is shown on 169. The next technique is shown on 171. The first 2 are shown on 169. The second 2 are on 171. So the first, notice it says that when you do this, it's 3 or 4 steps, but you'll always have to import the associated interface. All right, so you'll have to do that regardless. Then you can use the current class as a listener, and I believe that's what we've been doing. All right, so what do you have? You've got public, the tip activity, then inside of there, we did an override. So we've done things like this before. Now when you do this, you have to also set up, as it says, you have to set up or wire up, however you want to put that, the particular listeners. So in chapter 3, we learned about how to do this, and this is kind of a review, for lack of better words. Again, you must start by importing the listener class regardless of which of these ways you use. All right. So the code here uses the tip calculator activity class, and it implements the on-click listener, or the on-click method, defined by the on-click listener interface. Then it wires up the buttons, and it uses the this keyword in order to do that. A second way that you can do this, you create a separate class named button listener that handles the events. The reason that this is important, since it's a separate class, this first way was done right inside of this class. So this is called a nested inner class. This is a separate class. The code is virtually the same. The button listener class still implements the listener interface. The class is stored in this, the code is very similar to what you saw earlier. This is called a named class, okay, because it's outside of the other class. If you want to, the third example on page 171 shows how you can do this without specifying a name for the class. This is also known as an anonymous class. But you'll notice the code that's in here is the same here, and here, and here. Finally, the fourth way, show us how you can handle the click event without assigning the listener object for an instance variable. To do that, you create an object for the listener within the parentheses. All right? So in other words, rather than having the code in a separate method, you wire it up in the particular on-click listener for the particular, in this case, button. Now, most of the time, any of these will work. So it's a matter of personal preference. The author mentions on the bottom of page 171 that he recommends the technique that results in the most reliable and maintainable code. And that he recommends that you use one method. He uses the first technique, even though it's not necessarily the least amount of code, all right, but in his opinion, it results in the most intuitive or straightforward code. All right, let's talk about some high-level events. And we've looked at some of this already. But when we take a look here, and again, the idea behind this particular chapter is not so much that I'm going to go and write a lot of code, because all the code that's in here has basically been written before. We did this before with this remember tip percent. We did this in the last chapter. This would check to see whether or not, all right, whether or not something, in this case, you're checking to see whether the check box is checked or not. So you've got this variable, it's a Boolean variable called remember tip percent that's set to true if this is checked and set to false if this is not checked. So it's this check changed event, and you use that for either a radio button or a checkbox. It occurs when one of them or the other is checked or unchecked. The first parameter that you send in there, all right, it's called a compound object. And it can be cast to a checkbox or a radio button object. The second parameter indicates yes, this is checked, or no, this is not checked. Now that's for a checkbox or a simple radio button. But remember, radio buttons can be placed inside of groups. So you've got here the check changed event of a radio group. All right, that occurs when a new button within the group is checked. The first parameter is the radio group object, and the second one is the ID of the radio button in there that's going to be checked. So this would be checking which one of these indeed was chosen. So you're calling calculate and display, but you're either calling it and letting it know that it's doing no rounding, or that it's rounding the tip only, or that it's rounding the total only. Again, we could have put a fourth button in here that said round tip and total. All right, we would have had a new case in there, etc. For the spinner, again, we created one of these in the last chapter, and that's why I'm talking about them now, and I'm talking about them in this manner. All right, so for the spinner, you can see here it's on item selected. That's what's executed when the spinner is first displayed and whenever a new item is selected. All right, a new item. So if you're on an item and you select it again, of course, it's not going to run. The third parameter that's in here provides the position of the selected item. The on nothing selected method is executed when the selection disappears. Typically, it's not going to happen or happen often. The seek bar, which we also did in the last chapter. All right, there's on start tracking touch when the user begins to change the value of the seek bar. There's on progress changed, which we've used before, and that's executed when the user changes the value of the seek bar. There's on stop tracking touch, which we've used before, when the user finishes changing the value of the seek bar. And there's on progress changed. All right, that's the second parameter that provides the progress value for the seek bar. So we've looked at this at least somewhat in the past. All right. Since they're using a tip percentage in here, they're dividing it by 100 as well. Now, the next thing that's in here, starting on page 180, is they talk about how to handle some of the low-level events. All right, first they talk about how to handle key events. And with key events, if we look here, here's some of the constants that you can use with these. Key code enter for the enter key. Key code D-pad center for the center key on the D-pad. D-pad left for the left key on the D-pad. D-pad right for the right key on the D-pad. And key code space for the space key on a hard keyboard. So the key event class has constants for basically every hardware key on the device. It returns a Boolean value that indicates whether or not, basically, they say in the book here that this has been consumed. If you don't wire an event handler to multiple widgets, if you don't want to do that, you can wire it to the parent widget. You can also use the get system service method to get an input manager object and then work with that. Touch events. The onTouch method returns a Boolean value that indicates whether or not, again, this has been consumed. So when a user touches a widget on a touchscreen device, a touch event occurs on that widget. Most of the time, you don't need to know how to handle this. Rather, you can use another event, like a click event, to get this to work the way you want it to work, but not necessarily always. So they jump back here, and the chapter finishes by showing what the author calls a new and improved tip calculator. Now, to say new and improved, that's a relative term. You may or may not agree. You know, to me, looking at this particular tip calculator that you see in here, for lack of better words, I find this tip calculator that's shown here to be a bit busy. I have no problem with this, but adding all of this stuff in there, all right, just makes it a little hard to read. So you're doing no rounding, but you're splitting the bill 3 ways so you can see what you have to do. Okay, so this version includes the seek bar for the percent, the radio group for the rounding, that includes the 3 radio buttons, and a spinner for splitting the bill. To set a new tip percent, you can, if you're running this on a actual device, you can drag your thumb on the seek bar. To round the tip or the total, you can select the radio button. And to split, you use the spinner. Now, on pages 187, 188, 189, and 191, 192, and 193, they show you the Java code for what, the author calls the new and improved tip calculator. Let's just talk a little bit about what's new. The first thing that you're going to notice when you look in here is there's a lot more import statements that you have because there's new widgets that you're using. In addition, when we get into here, notice we're now importing 1, 2, 3, 4, 5 different listeners. So when we do that, we also need to get a reference to all those new variables that we're going to be creating in here. So we declare them, and we're needing to get the references. All right. In addition, we're setting constants for the rounding. That looks pretty similar. You know, again, there's stuff added to it. But when we look at the calculate and display method, it works pretty much the same way it did when we first created it in Chapter 3. But it has new code that rounds the tip and the total if necessary. It also contains new code that calculates the split amount, shows or hides the per person label, and formats the per person label. All right, so anytime you increase the complexity of an app, it just should make sense that you will increase the code that's going to run with the app. All right, so Chapter 6, and again, I realize I didn't go into the actual code here, but the idea with Chapter 6 is you should have an understanding of the difference between high-level events, which occur on just certain widgets, and low-level events, which can occur on each and every kind of widget. As always, if you want more, there's more inside of, developer.android.com. So I'm going to come back, and I don't know if this is effective or not with what I'm doing here, but I'm hoping it is at least. And next, I'd like to go over Chapter 7, which begins in the book on page 197. Not a particularly long chapter, but talks about themes and styles. So I'll be back with that shortly.